Hi, everybody, and welcome to part two of this week's lecture. What we're going to try to accomplish today is we are going to understand what a solvent is and why water is such a great solvent. We're also going to look at the relationships between salt, so NaCl, and water, H2O, and what's happening when we add these together. We're not only going to be able to identify the difference between a solvent and a solute in this example, but we're also going to see molecularly what's happening when we add them together. So let's go ahead and get started and identify exactly why water is going to be a solvent. Now, one of the very first things we need to identify is exactly what a solvent is. So a solvent is just going to be a liquid that can dissolve other substances. Okay, so again, a solvent is going to be a liquid that can dissolve. So it has the ability to dissolve other substances in order to create a solution. Now, we do have something that's going to be known as a solute. And what a solute is any substance that can be dissolved. Okay, so a solvent is a liquid that can dissolve. A solute is what's being dissolved. And when you add both of these together, you end up with a solution. Okay, so you add a solvent and a solute, and that is going to give us a solution. So now that we covered those two major terms, we can go ahead and look at our example right here, which is going to be our salt, our water, and then our salt water. So looking at this, our solute, so the thing that can be dissolved, is going to be the salt. And when you add that salt into water, which is our solvent, because remember, solvents are liquids that can dissolve. So water is a liquid and it's dissolving our solute, which is our salt. And when we add those two together, we end up with our solution, which is going to be salt water. So again, our solute, which is salt, is being added to our water, which is our solvent, which can dissolve things in order to produce our our solution. So again, solute, solid, salt, solvent, which is going to dissolve, which is water, is creating our solution, which has our solvent and solute together to create our salt water. Now, I'm sure you're wondering, hey, Mr. Chang, why are you putting so much emphasis on salt water? Why is salt so important? What's up with water? We know water has some important properties, but what's up with the salt? Why are you focusing on it so much? Well, one of the big reasons why is because salt is going to be very, very prevalent in the human body. And as you move on with your science classes, you're going to learn that salt is actually going to cause contractions within the body. So this is a great way to introduce what salt is, what that solution is going to look like, how taking salt and our solvent, water, can produce electrolytes, which are going to help elicit, again, some of those contractions. All right, so now that we went ahead and looked at what a solute and a solvent is, and we applied those concepts to salt water, and we looked at exactly what is going to be the solvent and what's going to be the solute, what we're going to do now is we're going to look at it more molecularly as to what's happening. So you can see over here that we have a beaker, and that's going to be full of salt water. So remember, in this case, our solvent, remember solvent can do the dissolving H2O, is dissolving our solute, which in this case is salt and NaCl. You add these two together, and remember, we're creating this right here, salt water. Now, what's happening here is water is also going to be a polar molecule, and this is why it can dissolve those substances. Remember, polarity, we're looking at charges. So if we can think back to our first part, we have all of our deltas. Remember, we have either a delta positive or delta negative. Because remember, delta is representing a partial or difference in charge. So some can either be partial positive or partial negative. So what's happening here is when water, because it's a polar molecule, dissolves those substances, what's happening is it can cause something known as dissociation or dissociate. So just like the name suggests, dissociate just means separating or going apart. So one way we can kind of look at this is NaCl is our molecule. It contains our two elements, sodium and chloride. And right now they're together, everything's great. They're exactly kind of what they want to be at the moment. But once you add this to water, they're going to disassociate. So if you think about this as like a relationship or a friendship, they're all good all the way up until they get in contact with water. What happens here is they have a big fight. And just like you might disassociate from a friend or disassociate from somebody you don't like, they're going to split apart, disassociate. So sodium is going to go one way, chloride's going to go the other way. And they're going to disassociate into Na plus, so slight positive charge, and then Cl minus negative charge when placed in water. So again, we have our solvent, which is water, and our solute, which is sodium. What happens is when you add them together, because water is a polar molecule, we have a slight positive, slight negative charge. We add this together, they're going to disassociate. NaCl is going to disassociate in the solution, giving us Na plus and Cl, giving us salt water. Okay, so I know that was a lot. So we're going to go ahead and take a look at this diagram to see what that disassociation is going to look like. So looking at this over here, this is going to be a representation of our salt molecule. Again, salt is NaCl, and you can see it's made out of sodium ions and chloride ions. So we have a positive sodium and negative chloride. And remember, our water and our oxygen also have those partial positive and negative charges. So remember, our oxygen over here has a partial negative charge, and then our hydrogens over here have a partial positive charge. And because of that, whenever we have this dissociation, remember that splitting apart, what's going to happen is the water molecules, the oxygen side or the negative side, is going to look for those positive ends. And then what's going to happen is the hydrogen sides, the positive, are going to be looking for the negative ends. So this is what that disassociation is going to look like. Because our sodiums are positive, they're going to be naturally more inclined to go with the negative side. And then the chloride, which is negative, again, is going to be more inclined to go to the positive side. Again, if we think about a magnet, like in our previous analogy, positives are going to look for negatives, and negatives are going to look for positives in order to come together. And that's what's happening here. Again, our chloride negatives are looking for those positives, which again are going to be in the form of our hydrogens. And then our sodium's positives are going to be looking for those negatives, which are going to be in the form of our oxygens. All right, so that is going to conclude part 2 of our solute, solvent, and our disassociation. So what I would like you to do now is I'd like you to go ahead and test your knowledge and see if you can do questions 1, 2, 3, and 4. I'm going to go ahead and give everybody a moment to pause this and try this on your own, and then we'll come back together and look at it together as a class. All right, welcome back, and let's go ahead and check out some of these answers. So looking at number 1, it's asking which of the following best defines a solute. So remember, we have our solvent, which is going to be a liquid. And then our solute is what's being dissolved. So in this case, we have a solution or substance that dissolves in a solvent. So this would be A, because remember our solvent is what's dissolving. Our solute, I'm sorry, yeah, our solvent is what's dissolving. Our solute is what's being dissolved. All right, so in number 2, it says, which of the following best defines a solution? Now, it is important that all of these aren't necessarily going to be correct. It's just C, the reason why this is going to be the most correct is because it's asking to define a solution, and it's a liquid that can dissolve a solute. Okay, so a substance that dissolves in a solvent is definitely going to work. A mix of a solution, so solvent and solute, is absolutely going to work. And then D, a solution that dissolves in a solute that dissolves in a solution is going to work as well. In this case, best way to describe a solution is a liquid that dissolves a solute. But again, A, B, and C are going to work as well. When it comes to number 3, NaCl salt placed in water dissociates into, so remember we have NaCl, which is going to be our solute, and then we're adding that with H2O, which is going to be our solvent. And remember, we have that dissociation, so remember these two are going to separate out, go their own separate ways. And then we have our Na, which is going to be a positive. We have Cl, which is going to be negative. So then remember, Na is going to want to get with the partial negative of our oxygen. And then our Cl is going to want to get with our partial positive for our hydrogen. So for the answer for this, because they're disassociating, they're going to be separating into their own individual components, NaCl. But remember, we have partial charges, so positive, negative. So the answer would be D. And then finally, for number 4, sodium ions in water orient themselves to the partial positives as negative charges of oxygen atoms located in water molecules. In this case, sodium ion, remember sodium is going to be a positive, so Na plus. Remember, a magnet, the positives want to get with the negatives, and then the negatives want to get with the positives. So in this case for water, remember H2O right here. Our hydrogens have that partial positive, and then our oxygens are going to have that partial negative. So the answer for this one would be A, negative. All right, and again, that concludes part 2. So as usual, if anybody has any questions, comments, concerns, please feel free to reach out. Again, best way to get to me is going to be on Canvas. And I look forward to seeing everybody in part 3.